You can also evaluate limits analytically. So far, we've discussed evaluating limits graphically, and we've discussed evaluating limits numerically, which was using the table of values. So now we're going to talk about evaluating them analytically, and the first method I'm going to talk about is the direct substitution method. Remember, you can pause this video at any time to copy down your notes, but I do want you to copy everything that I write. So the direct substitution method says to evaluate the limit of f of x as x approaches c, try substituting c in for x. So if you look at this example, the limit of negative 2x squared plus 4x plus 2 as x approaches 1, my c value is 1. So I'm going to go ahead and directly substitute that 1 in for x. And then we go ahead and use algebra to finish it off to get our answer of 4. Now, if you look at the graph of negative 2x squared plus 4x plus 2, it'll make sense why the limit as x approaches 1 of this function is 4. So remember, this is just a parabola. This is the graph for negative 2x squared plus 4x plus 2. So here we have x equals 1. So as we approach x equals 1 from the left side, we get really close to it from the left and the right side. We're approaching an output value of 4, which is why the limit of this function as x approaches 1 is 4. So in other words, if f of c is defined, then the limit of f of x as x approaches c is equal to f of c. So this makes sense because it just happens that f of 1 is defined for the graph. F of 1 is defined, and we know that f of 1 is 4. Okay, the vertex, 1, 4. So because this worked, the limit of this function f of x as x approaches 1 is 4. Okay, so that's the direct substitution method. It tends to make finding limits easier. Now, before we do more examples, I want to go over some properties. Okay, so go ahead and copy these properties down. There are 6 of them. You can pause this video at any time, rewind it whenever you need it. But I want you to just copy these properties down for the record, for your notes, and then we'll look at examples. They look harder than they really are. Once we put it to practice, you'll see that it's really easy. So it looks a lot harder than it really is, but once we put this to practice, it's really easy. Alright, so knowing these properties, we can solve problems like this. Let's say, given the limit of f of x as x approaches 3 is equal to 5, evaluate the limit of f of x squared as x approaches 3. So look through your properties. Which property do you think you can apply here? And this is actually property number 5. So what we do is we go ahead and write the limit of f of x as x approaches 3 squared. So our answer here will be 5 squared, or 25. So that would be your answer. Here's another example. Go ahead and copy this one down. If we're given that the f of x is equal to x squared and g of x is equal to x plus 1, and they want you to evaluate the limit of f of g of x as x approaches 2, well, what property does this look like? This is just property number 6. So all we have to do here is, this is now f of the limit of g of x as x approaches 2. So the limit of g of x as x approaches 2, that's just, now we know that we can do direct substitution, so that's 2 plus 1, which is f of 3, and that's just 3 squared, so we get 9. Again, through practice, this will be a lot easier. Okay, so that's the answer here. Okay, and now I want to go ahead and finish this video with an example of direct substitution, which is what I started the video with. So if I directly substitute, I said that you want to try direct substitution first, direct substitution method. But in this example, the limit of x squared minus 4 over x minus 2 as x approaches 2, we have a problem. We have 0 over 0. This does not work. We call this indeterminate form. Okay? So how do we deal with a limit if we are asked to evaluate this and analytically? We do the direct substitution method, but we get this 0 over 0, which is called indeterminate form. Well, one thing that you guys need to start practicing is that when you get 0 over 0 or indeterminate form, that is not an answer. However, indeterminate form tells us that we can do some kind of algebra to simplify the function. Okay, so x squared minus 4 over x minus 2. By us getting this indeterminate form, we know that we can simplify this somehow. So how are we going to simplify that? So if we factor the numerator, so we have the limit as x approaches 2, but now we have x plus 2 over x plus 2 times x minus 2 over x minus 2. Well, we can simplify, and now what we're looking at is the limit of x plus 2 as x approaches 2. And the way you would solve that now is, again, direct substituting. And you see that this time we get an answer of 4. And this 4 has no relation with the answer 4 that we got in that very first example. Obviously, this is just a coincidence, but this is how you would solve solve a limit analytically if you get indeterminate form when you directly substitute the first time. That is all that I have for this video.